going back to the context of something like this FIR filter, what it means is that with this as my original diagram, right, if I wanted to have some kind of a division that allowed me to sort of say, okay, everything to the left is going to work on sample number 1 and everything to the right is going to work on sample number 2, what I actually need to do is to be able to take my entire circuit and divide it cleanly into left and right. Okay? One way of doing it is to say I will put a division like this, okay, and say that this is handling one side of the processing, this is handling another. Okay. So, these are like the workers on the factory floor. Whatever is to the left of the red line is working on car number 2, whereas whatever is to the right is working on car number 1 or sample number 1. Okay. I can go further and do this again over here and say that I now have 3 divisions. Okay. So, now this basically works on sample 3, this works on sample 2 and this works on sample 1. What do I mean by that? It means that I can actually explicitly put registers over here and over here, right, and what I am going to get finally at the output is this will correspond to y of n minus 2 because it has been delayed by 2 steps. At any given point in time when I give the nth sample to the input of the overall system, what I am going to be getting at the output is something that should have come 2 clock cycles earlier or 2 samples earlier in my original design, but now is basically delayed by 2 samples. Okay. So, you can understand what is happening over here. In terms of when is the output coming, it has now been delayed by 2 samples. At a given point in time when I expected to see y of n, I am going to see only y of n minus 2. That is latency. I can live with latency in general, right. On the other hand, my clock period itself has been reduced. What has it been reduced to? Now, what is the critical path? It has improved, but not as much as I would like, right, because the critical path now is Tm plus Ta, right, and similarly over here also I have one Tm plus Ta. This has reduced to Tm, but the problem over here is there is at least one path which has Tm plus Ta, and that is going to be the ultimate critical path as far as my overall circuit is concerned. Okay. So, yes, this improved matters, but it has not improved things as much as I would like. Part of the reason for that is I chose the wrong lines for doing my pipeline separation. Okay. Let us see if I could have done it slightly differently. That is also very easy actually to do. All that it is saying is, why not choose this as my division, right. This whole notion of left and right and what is happening before and after are just some physical constructs that we are using to visualize. All that really matters is logically what is happening before what. And if I use this as my division and put registers over here on these 3 edges, now what does my critical path look like? Over here it is Tm, over here it is Tm, this is Tm, and this last one is 2 Ta. So, that my critical path becomes max of Tm and 2 Ta, which in this case is 2 nanoseconds, both of them are 2 nanoseconds. Okay. What is the core idea that we applied over here? We needed to delay all the intermediate computations by the same amount so that the output functionality remains unchanged. We saw earlier in the other example of that simplified filter that if I just put one register on one of the paths and not on the other one, I will completely change the transfer function that is being implemented. So, I can't do that, right. So, this dashed red line that I drew over here, right, is effectively dividing the circuit completely into a before and after segment. Okay. And as long as I do that complete division into a before and after segment and I am able to introduce registers on all the edges that go across that, right? It's a safe transformation. I can safely introduce registers over here without changing functionality, and by introducing registers over there I can hopefully reduce my critical path, and this is a valid pipelining. Okay. This is something called a cut set, right? It is a set of edges that I can identify in the graph where all edges basically go from one side to the other. Okay, I am not going to say from left to right or from front to back or anything of that sort, because that depends on how I draw it. What is important is logical flow of information. There is a before and an after, and everything flows from the before side to the after side. And as long as I can find that by removing these edges, my graph or my system completely separates out into a before and an after segment, it means that I can introduce registers on all of those edges, exactly the same number of registers, and the only change in functionality will be an overall delay in the final output. There will not be any change in transfer functions other than that.